Welcome to section 8.3, Graphing Reciprocal Functions. If you look to the right side, follow my cursor, you see that I'm circling the function 1 over x. More specifically, this is the parent function 1 over x, and with the parent function there are no transformations. So in this unit we're going to cover transformation, identifying domain and range where it's going to be connected with the asymptotes and excluded value. Then we'll talk about how to graph, and I will show you one or two examples on how to graph using the information just like how we did in 8.4, such as identifying asymptotes and x and y intercepts. So for the parent function 1 over x, if you look at the right, the graph in blue, that's what the graph is going to look like for 1 over x. Now let's cover transformation. So if you look at the right side, at the second line where it says 1 over x minus 2, we're going to ignore the plus a for the moment, but mainly focus on x minus 2. So when we have a number that is behind the x, we saw that in the square root, the cubic, the quadratic, and the absolute value, whenever they have a number behind the x, we saw that the transformation was left or right. So let's take a look at what happened if it's x minus 2. So the graph is in green. If you look closely from the blue graph, which is the parent function, 1 over x, and compare it to the green function, 1 over x minus 2, you notice how the blue graph, went 2 units to where the green graph is. So if it's x minus 2, that means it's going to shift 2 units to the right. So let's see what happens if we change from minus 2 to plus 3. So let me scoot over with the graph. So if it's x plus 3, we see that from the blue graph to the green, it shifted 3 units to the left. So here, with the function and the graph, I would recommend to write down the transformation to see what it is. You can just briefly copy the graphs in your notes, but again, I do recommend that you write down the information as I'm going through this. Mainly the transformation, how to identify transformation, such as here, whenever we have a number that's with the x, that means that it's going to go left or right. So if it's minus, it's going to go to the right. If it's plus, like the plus 3, then it's going to go to the left. So let me bring back the minus 2, and then I'm going to deactivate the parent function, the blue graph. What we're going to focus on is the plus a. And you're going to see how it's going to connect it with the horizontal asymptote. So just like how we did in 8.4, since we have a number in the numerator, that means that the degree is 0. The degree in the denominator is 1. So that means that the numerator degree is less than denominator degree. So whenever that happens, then the rule is we have a horizontal asymptote y equals 0, which I'm going to turn on right here in orange. So here's the orange graph. This is the horizontal asymptote. Now, we want to see how it's connected to its transformation. So going back to the green graph, 1 over x minus 2. Now, we're going to work with the plus a. So the plus a, if you see where it's added with a number or subtracted with a number, so you're going to see the transformation. So I'm going to turn on my slider right here for my a. So instead of a was 0, if a was 2, like so, you see that it shifted 2 units up. So therefore, my new horizontal asymptote is going to be at y equals to 2. Now, what happened if a wasn't positive 2, but a was minus 3? So, as you saw me sliding the number for a, you notice that the green graph shifted down 3 units. So that means that if I were to change, then my new horizontal asymptote is going to be at -3, as shown with the orange graph. So what happened if I were to move to -4? Then the same thing is going to happen. My horizontal asymptote is going to go with the transformation, and now my horizontal asymptote is y equals -4. So if you have a number behind the fraction +1, -2, +4, -5, then that number you're going to use, that's going to be the number for your horizontal asymptote. So we're going to be using this to determine transformation, and then identifying asymptotes, x-intercept, y-intercepts. You're going to need all that information for your graphs. Now let's talk about domain and range. So I'm going to turn off, well, I'm going to leave my horizontal asymptote on, and then I'm going to turn on my vertical asymptote, which is shown in red. Now, I'm going to zoom out of the graph. If you look closely at the green graph, as you can see here, we have the green at the bottom left and at the top right. Now, at the ends of the green graph, we have arrows. Now, you won't be able to see it because the graph is continuous. So, if I were to look at the left, bottom left, you see that towards the left side, if you follow my arrow, that this graph is going to go forever towards the left. And then if you look at the top right, as you follow my cursor, you see that the graph, this part right here, is going towards the right forever. So if the left side of the graph is going forever to the left, that means it's going towards negative infinity. And then the right side of the graph, if it goes forever towards the right, then it goes towards positive infinity. And that's for the domain, because I'm talking about left and right. But the issue is here. If you look at the red line, the vertical asymptote, where it's at 2, here, the parts, this is where the graph will split. So vertically, if you look at the green graph, it will not touch each other at 2. So for my domain, it's going to be all real numbers except for 2, where my vertical asymptote is. So if you were to identify domain range, for domain, you would just write all real numbers, or all reals, except for 2, where my vertical asymptote is located. Now let's talk about range, the up and down. So let's look at the top part, so the top right. Follow my cursor, you see that the graph is going upward forever, so that means it's going towards infinity. Now let's look at the bottom part of the graph. You can see that if you follow my cursor, that it's going to go downward forever. That means it's going to be towards negative infinity. So if it goes towards negative infinity and positive infinity, it's basically all real numbers. But the issue is, if you look at the horizontal asymptote for a reciprocal function, in this case, the green graph, will not cross the horizontal asymptote. That means that there's going to be a split. Since the green graph is not going to cross each other or touch each other, that means that for the range, it's going to be all real numbers except for -4. That's where my horizontal asymptote is located. So if your horizontal asymptote is at -4, that means my range is going to be all real numbers except for -4. Now, if the graph, if it was transformed, say that it was 1 over x minus 2 plus 3, as you can see, the graph shifted up 3 units. Therefore, my horizontal asymptote will be at 3. So that means that for my range, it's going to be all real numbers, or all real, except for 3. So that's going to be the process on identifying domain and range. So we covered identifying transformation and identifying domain range. I'm going to do some examples when given an equation to identify vertical, horizontal asymptotes, x-intercept, y-intercepts, transformations, and domain range. Then we're going to use the information to make our graph.